Welcome back. Today's goal of this lecture. In my previous video I had seen Cauchy's integral formula. In my previous video I had seen if f is analytic on a simple closed contour C and the point A is inside on the closed curve C, such type, then integration fz dz over z minus a equal to the value of integration is 2 pi I times value of the function at the point A, where A is the point inside on a closed contour. Previous video I had discussed this part briefly, and also I had seen if f is analytic within on a closed contour C and A is enclosed by C, then integration dz over z minus a, this value is 2 pi I. But integration dz over z minus a to the power n, when n equal to 2, 3, 4, so on, then this value would be 0. This is I had seen in my previous video. Today's goal of this lecture. In my previous video I had seen the Cauchy's theorem is f equal to 1 over 2 pi I integration fz over z minus a dz. Today I will see actually extension of Cauchy's theorem, which is if a function fz is analytic within and on a closed contour C and A is any point within C, then derivatives of all order are also analytic, and given by fn A equal to n factorial over 2 pi I integration over C fz over z minus a to the power n plus 1 dz. This is our today's goal of this lecture. Actually, what is the extension of Cauchy's theorem? At first, evaluate the integration 3z minus 1 over z cube minus z dz, where C is the counterclockwise direction in this region. And here, this is written as integration C 3z minus 1 z times z minus 1 times z plus 1 dz. Notice in this contour minus 1, 0, 1 included. That means in this point the function has singularity. Here, today's goal of this lecture, at first I will tell you by this example you can easily understand Cauchy's theorems, Cauchy's integrals theorem, why very important. If we just break this integration to evaluate this integration, then this method would be more complicated than the Cauchy's integral formula. At first, I will see the first method. This is not more easier method. Just fraction it, and this fraction we all of us know, this is to find this fraction, this is more difficult. This is, if you evaluate, then this value would be 1 over z minus 2 over z plus 1 plus 1 over z minus 1. Notice here the singularity at the point 0, 1 and minus 1. Consider C1 along the contour 0. Then integration along C1 fz dz equal to integration along C1 1 over z minus 2 over z plus 1 along C1 plus dz over z minus 1 along C1. And along C1 means here included only 0 point. So here along C1, here function has no singularity, so this value would be 0 by Cauchy's integral formula. And we all of us know, if we put z equal to e to the power I theta, then this value is 2 pi I. Now we have to find this integration along C2. Along C2 means contour along the point 1. Along C2, 1 over z dz minus 2 dz over z plus 1 plus dz over z minus 1. Along C2 means along the point 1, along then here function has no singularity, so this value would be 0. Also this value would be 0. Only we have to evaluate this integration z equal here singularity at the point 1. And we all of us know dz over z minus a, this value is 2 pi I. So this value would be 2 pi I. Along C3, where C3 equal to contour on the point minus 1, then this value would be C3 1 over z dz along C3 minus 2 1 over z plus 1 dz plus 1 over z minus 1 dz. Along C3, this value would be 0. This value would be 0 because here singularity only at the point minus 1, here singularity at the point minus 1, and this value would be minus 2 times 2 pi I. So this value would be minus 4 pi I. So that means the value of the integration is 2 pi I plus 2 pi I minus 4 pi I. That means this value is 0. Okay. Now I will see the Cauchy's integral formula. At first I will evaluate the Cauchy's integral formula along the contour C1. 3z minus 1 z cube minus z. Since here along C1 means here the singularity at the point 0, so here would be just right. Here f would be 3z minus 1 over z square minus 1 over z, because at the point z, at the point 0, the function has singularity. So by Cauchy's integral formula, this value would be 2 pi I times f of 0. Just put the value 0 because here this part is f. Then this value would be plus 1, that means this value is 2 pi I. And along the contour C2, C2 means here the singularity, since at the point 1, so rewrite as this such way 3z minus 1 over z times z plus r 1 over z minus 1 dz along the contour C2. Here the singularity at the point 1, so consider this is f. Now put the value 1, then this value would be 3 1 minus 1 over 1 times 1 plus 1. This value would be 2 over 2, that means this value is 2 pi I. And along the contour C3, since here the singularity at the point minus 1, so along the contour C3, this value would be 3z minus 1 over z times z minus 1 over z plus 1. Since here the singularity at the point minus 1, so this value, since this value is f, now put the value, then this value would be 2 pi I times f minus 1. Just put the value and after calculating this value would be 4 pi I. Sorry, here this value would be minus 4 over plus 2. That means this value would be minus 4 pi I. So integration along fz dz over c means integration along c1 fz dz plus integration along c2 fz dz plus integration along c3 fz dz, and this value would be 2 pi I plus 2 pi I and here minus 4 pi I. Similarly, this value is 0. But this is Cauchy's integral method. This method is more easiest method than the before method. I hope my all viewers have understood why I have told you Cauchy's integral formula is more important than the other method. Okay? Well. I will see another example. Integration cos z dz over z square plus 1. Where gamma, this region is simple closed curve which is oriented in positive sense, lying in the upper half plane and containing I in the inside of gamma. That means gamma is a smooth curve which is centered in the point I in the positive sense. Then integration cos z over z square plus 1 dz, this is equal to, we can write this as cos z over z plus I z minus I. Since I is the inside of this region, so fz equal to cos z over z plus I divided by z minus I dz, and here fz is analytic. So by Cauchy's integral theorem, this is 2 pi I fa. Here a means I, so this value would be cos I over I plus I. That means this value is 2 pi I times cos I by 2i. Just cancel 2 I and I. Then this value would be, do all of us know cos I means e to the power I times I plus e to the power minus I times I over 2, and this means pi times e square plus 1 by 2e, sorry. And this is the value of this integration, pi times e square plus 1 over 2e. I hope my all viewers have understood the Cauchy's integral formula. Now I will see extension of Cauchy's integral formula. Extension of Cauchy's integral formula, this is actually derivative of analytic function. And the theorem is, if fz is analytic within and on a simple closed contour C or domain D, and if A is any point which is interior to the complex number, then it has derivatives of all order in the domain D which are also analytic. That means all derivative also analytic, and A is the point which is interior of this contour. Then the value of the derivative at a point A is fna equal to n factorial over 2 pi I integration fz dz over z minus a to the power n plus 1. This is the derivative of analytic function when A is inside of the contour, because we all of us know analytic means the function is differentiable at every point. That means f and z exist for all z belongs to D and n belongs to natural number. All order derivative exist in this region. This is the actual idea of analyticity, we all of us know. And a function is analytic means there exists a power series. k equal to 0 to infinity ak z minus z0 to the power k, where ak equal to 1 over k factorial f to the power k z0, and if a lies inside of this circle, then fn a equal to n factorial over 2 pi I integration fz dz over z minus a to the power n plus 1. And this is actually the extension of Cauchy's integral formula. Let's see some example. Fn a means n factorial over 2 pi I dz over z minus a to the power n. But the problem would be such type: integration fz dz over z minus a to the power n plus 1. This value would be 2 pi I over n factorial fn a. First example, e to the power z square over z minus 1 whole cube. Here the region gamma 0 2. That means circle of center 0 radius 2. Here fz equal to e to the power z square. So by these rules, here n equal to 2 pi I over 2 factorial. 2 factorial means obviously 2. Here double derivative e to the power z square, and first derivative of e to the power z square is 2z e to the power z square. So ddz of 2z e to the power z square is, here cancel 2 both side, then this would be pi I, and this value would be 2 e to the power z square plus 4z square e to the power z square, and this value at the point z equal to 1. And at the point z equal to 1, this value would be pi I times 2e plus 4e. So this value would be 6e times pi I. This is the value. I hope my all viewers have understood this is. Okay. Next example. After that, I will see one very interesting example. Integration along C z cube plus 3 over z times z minus I whole square. And here the contour is look like this is C1 with center I, and this contour is positive direction, and here the point 0, and contour is look like such type. Here 0 and I both included. But notice this is the positive orientation, but this contour, this is the negative orientation. So consider this is C1 and this is C2. So here the integration at first along C1 z cube plus 3 over z. Since here singularity at the point I over z minus I whole square dz plus along C2, but here the orientation is negative direction, so here would be not plus, here would be minus, because here the orientation is negative direction. Notice in this direction, this would be z cube plus 3 over z minus I whole square. Here singularity at the point 0, so z dz. That means this value is 2 pi I f prime I. Here 2 pi I, but here only Cauchy's integral formula. f0, singularity at the point 0, and here fz equal to z cube plus 3 over z, and f dash z equal to z square 3z square times z plus minus z cube plus 3 times 1, and this value is, here 3z cube minus z cube. That means this value would be 2z cube minus 3 over z square. That means f prime at I would be minus 2i minus 3 minus I square. That means this value would be 2i plus 3. That means this value would be 2 pi I times 2i plus 3. And f0, what is the value of f0? 3 over I square. f0 equal to 3 over I square. That means this value is minus 3. That means here minus 3, here minus 3. So this value would be 2 pi I times 3. So this value would be 4 pi I square plus 6 pi I plus 6 pi I. So that means this value would be minus 4 pi plus 12 pi I. I hope my all viewers have understood the value. Okay. This type of example very easy type but very knowledgeable. Okay. Today I will stop here. In my next video I will discuss some more result about this theorem. But at first I will hardly recommend you please see today's video with pay attention, because this topic actually very important for higher study, also for any competitive exam. See you soon, stay safe and stay positive always. Don't forget to subscribe my channel for more videos. Thank you so much.